Mathematics, Advanced Subsidiary Level, Paper 2, 2022, Part 6. Question number 9. The function f is such that fx equals log base of 2x minus 3 for the domain x is bigger than a, where a is a constant. Okay, find the minimum value of a. Now, if you go to my textbook, the AS-Level, on page 422, if you look at example 29, I think they use that exact, function. Okay, so that example is going to help you a lot. Okay, so logarithms are not defined for 0 or a negative numbers. Okay, so therefore, okay, you can write it out, but it's not necessary. So therefore, x minus 3, that part must be bigger than 0. Okay, it can be a half, it can be a fraction. Okay, remember that. But it must be bigger than 0. So if I simplify that, I get x is bigger than 3. So therefore, I will say the value of a is what? Because remember, there stands x is bigger than a, so the value of a will be equal to 3. Okay, let's just make that a. So that's the first one, just one mark. So for that value of a in a, find the expression for the inverse. Okay, now the inverse is easy. I make it a y, and I say log 2 x minus 3. And again, as soon as I did that, remember, where I see a y, I make it a x. Where I see a x, I make it a y. So make it x equals log 2 y minus 3. Okay. Now, don't forget, and that's so important, we used it so many times in the textbook, and I'm even going to check now for you where to find it. It's in the textbook, but that's converting. If it's in logarithms, I just want to see where did I do logarithms. It's converting from a log form to exponential form, or from exponential form to log form. And I'm just checking if I quickly see where in the textbook. I want to give you the page. So I'm just very quickly going through this. Oh, I see. So it's page 395, and there the chapter starts. So, sorry, I'm taking a little bit long, but I want to give you exactly that page. So make sure it's also going to be in the ordinary level textbook. Okay, but that's very, very, very important. It's now not the first time. It's on page 396. It took me. So page 396. Very important. Okay, so now I go from log form to exponent form. So I'm going to swap this two, and I keep the base. So it's like keeping the base and then make it x, and then it's y minus 3 on the other side. Okay, and now I can just make y the subject of the formula. So y is 2 to the power of x, and it's going to be plus 3. And then the inverse, okay, let's just write it nice. The inverse is going to be 2 to the power of x plus 3. As easy as that. Now, they state the range. Now, can you remember, and it's also in functions that I said that it's almost, say if you have a function, you have f, and you have f minus 1. And again, sorry, I'm going to search it for you in the textbook, because I want you to see in the textbook, and it's at functions, so it's chapter 3, and it's combined inverse functions. It's there at 108. I want to show you exactly the page. So I go to 108, but there it is, exactly on page 110. So if you go to page 110, you're going to see it. So, for example, if this is your function and this is your inverse function, so then if you have the domain, okay, I want to take another color. If you have the domain and you have the range, and you have the domain and you have the range, and then there's a nice picture that's showing you this. It's showing you this. So basically, if I have this is the function. Remember, this is the function. Let's just write. That was the function. So x is bigger. That was the domain. Okay, so the domain will be equal to the range of the inverse. Okay, and that's what they ask now, the range of the inverse. So instead of the x, so if this was x, and I want to take another color, sorry. If this was x is bigger than 3, this will also, but it will just be y is bigger than 3. That part will be the same, but instead of writing an x, you're just going to write a y. So that was very easy, just saying y is bigger than 3. Okay, coming from this principle. And then I go on, number C, the function g, now they bring in g, okay, it's a straight line, evaluate. Okay, so I always like writing f here, or in my first sentence, I can even do it here. Okay, so what is my function of f? Okay, so don't forget your original, it was there on top. So it's going to be log 2 x minus 3, and then gx equals 3x minus 2. Okay, and then now if they ask this, but now, oh, I forgot, it's not f, they're asking the inverse. So I can even write it down. So this was actually unnecessary. So the inverse, okay, just check, because now I waste unnecessary time. Okay, so I've in the inverse, I start with the back part. In the inverse, you substitute 3. So it's going to be 2 to the power of 3 plus 3, and that's going to be 8 plus 3, and that's going to be 11. Okay, and now it's like G11. So it's going to be 3, 11 minus 2, which is going to be 33 minus 2, which is going to be 31. So I can end up by saying GF minus 1, 3 is going to be equal to 31. That is my answer. Okay, I will now go to the report. So show that F1 cannot be evaluated. So the best will be to just do it first and to see why. So if I have G1, okay, so I put 3 and I say 1 minus 2. And if I do that, I'm going to get 1. Now if I say F1, and now I go into this equation, not the inverse. So it's log 2, and now we'll see what happens. So you're going to end up, and you cannot get negative. So you're going to end up with negative 2, which is not defined. It's not. You can press log negative 2, it's going to give you an error. So it's non-real or undefined. That will all be correct. Okay, let's go to the exam report. Okay, we are at the second last question. It's always nice. Okay, so let's just read. It's again a lot of things saying to you. Okay, so the first one, that X is poorly answered. Candidates did not understand the basic concept of the domain of logarithms. According to the definition, log A is only defined with A bigger than 0. That's where logs exist. This is the concept that was tested in this question. Many candidates wrongly concluded that A is equal to 4, referring to the first integer value in the given domain. X is equals 3 is the equation of the asymptote of the graph, hence the A value that was required. Okay, but that was what not, so it was X is equal to 3. Let's go on. Number B, extremely poorly answered. That's now the inverse, which it's not, because it's coming from ordinary level. So once again, candidates failed to convert, it was the log form, to exponential form. That's why I said go to that page and make sure you can do it. As stated before, candidates must be taught that if log B is then going from log to exponential. A common wrong answer seen was this, from the misconception that log 2 can replace by 2x in the inverse. It should be noted that the y in the final answer must be replaced, very important, with the inverse to score full marks. You cannot stop with the y. Okay, and then the next one, it's now that range, poorly answered. The majority of candidates realize that by taking the inverse, the x and the y are interchanged, the domain range are interchanged. Some candidates realize this, but wrongly wrote the range as x. Range is y. Okay. So instead of y is bigger than a, it should be noted that candidates could use any wrong value they found in part A in this question correctly and still scored full marks. So it's just, it's a follow through. So they test if you answer in A, they would not penalize you if you use the same, but just put a y in front. That's what they're saying. Now, number C, it seemed that the notation of compound functions still presented some candidates with difficulty. Although it's part of the ordinary level syllabus, some candidates still thought that they needed to multiply the two functions with each other instead of applying the principle of compound functions, that you start from the back. And then this first one was now the evaluation, poorly answered. Many candidates attempt to find the inverse of GF. They misunderstood the notation that the solution of f must be substituted. Now, as I said, go back to ordinary functions. If you struggle, before you go to AS-level functions. And then the last one, moderately answer. Most candidates could reach the state where they evaluate this, but struggle to explain why it cannot be evaluated. The easiest reason would be to just refer to the domain of f found in part A, that would, because it was bigger than 3. Candidates should please not use any made-up abbreviations that they use in school that is not commonly known. Candidates need to realize that they can only write down the word undefined or non-real instead of trying to write a sentence in which the mathematical meaning is not. So undefined or not real was good to write. It should be noted that log, an expression, and the reason could not refer to this. Maths errors are not maths error or no answer are not applicable as acceptable. So don't write your calculator is giving you a maths error. You can test it, but you cannot write it. It's not formal correct. Another common mistake was to state that logs cannot be negative. Logs of any functions are negative. Log of a negative value cannot be evaluated. So it's not the answer, but it's the value. Okay. Cannot be, and that is a valid reason. Okay. As candidates, so just check that wording that you write it correct, because you can get a negative answer after you pressed log in, say log whatever, a fraction maybe. Okay, so I just want to test if a log a fraction, just for the interesting, log 0.5. Yes, log 0.5 gives a negative answer. But as I said, you cannot get log of a negative value. Okay. So any candidates need to explain the significance of their answer. They could not just write this without any simplification, and they concluded with their reason. Okay. So there they gave you all the answers and the way we arrive at the answers. Question number 10. The parametric equation of a curve are, okay, equations. X equals this, y equals this. And theta is between 0 and a half pi. So already it's all in radians. Okay, so your calculator at the end must be in radians. So find the gradient of the curve at the point where theta is equal to 1 radian. Okay, now in the textbook, you can go to page 505 in the AS level, and you can look at example 37. Okay, and that's going to help you, I think, number A. But so let's just start. Let's write down the y is equal to 5 cos theta. Now, what I personally think, what made this question paper a bit more challenging, that there was a lot of trigonometry in the further differentiation and integration. So make sure you know that. Okay, so when you go, and as I said, this will help you. If you go to your formula sheet, I'm busy with differentiation. Remember, just what are you busy with? I'm busy with differentiation, and I'm going to differentiate cos, And if I differentiate, it's going to be negative sin x. Okay, so the formula sheet can help you. Okay, so basically, if I'm going to have dy over d theta, so that one, and that is going to be equal to 5 negative sin theta, which is equal to negative 5 sin theta. Okay, now let's do it with x. So x is equal to 4 cos 2 theta. Okay, so plus 3, I forgot almost, plus 3 sin theta. Okay, now don't forget that, and you can find it also in the, so if you cos, it will also become sin, but it will just be, so can I just write it? So dx over d theta, it's, and remember with differentiate, we're just going to multiply with the 2 in front, okay? So it's going to be 4, let me roll it out, and then it's going to be negative sin, so make it negative 2 sin and keep the 2 theta. Okay, so plus, and then 3, this will be cos theta. Okay, and you can see that on page 516. I said here something, page 516. You can check there. Okay, now for this one, I must swap it around. So d theta over dx, and now it's just going to become, okay, this is going to become, so it's 1 over, and now it's negative 8 sin 2 theta plus 3 cos theta. Okay, why? Because I want to get dy over dx. So x must be at the bottom. So basically, to do that, I'm going to say dy over d theta, which I have there. Okay, multiply d theta over dx. Okay, so let's just multiply. So can I just highlight? So it's this and this. So if I multiply, I'm going to say negative 5 sin theta over 1 multiply 1 over negative 8 sin 2 theta plus 3 cos theta. Okay, now that is going to give me negative 5 sin theta, I'm just putting everything over 1, negative 8 sin 2 theta plus 3 cos theta. Now, if theta is 1 radian, so if theta is equal to 1, then if I substitute, it's negative 5 sin 1 over negative 8 sin 2 1 plus 3 cos 1. Now, just take your calculator and start pressing in. Make sure your calculator is on radians. Okay, so put that setting. Make sure you can do it. I have such a simple calculator. So for mine, I just press mode 2 times, and then I press 2, and then I'm on radians. Okay. So the negatives can cancel out, but it's not necessary. We can keep it. So negative 5 multiply sin 1 divide bracket negative 8 multiply sin and then the 2 plus 3 multiply cos 1 close the bracket equal. And now don't forget what they say. Always first write down out your whole calculator display. 744207197, and then approximate it to 3 significant figures. And then you are correct. Okay. And that's how you do number A. Okay. I think now, because it's such long stories always in the exam report, which I like because it's a very thorough report. But I think let's just go to that, and otherwise it becomes too long to go back. So it's not 7, it's not, we are now already at question 10. That's very nice. It's the last question. Okay, so let's just see what they said at A. There's your answer, you can see. So it's moderately answered. There was no need to convert the double angle before they could be differentiated. Once again, the conversions was often confused with differentiation. Sadly, it was common occurrence that the Q was replaced by an X or an A, resulting in the loss of all the marks as the given variable was changed. Okay. If the derivatives, oh, sorry, my English, it's a bit late, were on the formula sheet and could be used directly. Teachers should take more care in the way the candidates display their work. 5 cos theta was often differentiated and wrongly written down as 5 minus sin theta, or rather as 5 in brackets minus sin, and which end up in the negative 5 in front. It was occasionally seen that candidates differentiated dx over d theta correctly, but made the mistake of changing signs if they substituted in the formula. Another common mistake was simplifying this to this, okay, and then, yeah, be careful for that's not one term. Do you see? Keep that negatives. The candidates did not realize that there are 2 terms in the denominator, and therefore the negative sign cannot be cancelled out, only if you have 1 over 1 term. Okay, that was all about question number A, and let's do the final question. Oh, it's a nice feeling. Okay, so we go for the final. Find the value of sin theta at the point on the curve where the tangent is parallel to the y-axis. And I wrote it so nicely for you on page 505. You will find it, the 37 number B. Just check that example. So if I now have my differentiated equation, dy over dx, I'll write it now again. Don't, as I said, keep the negatives. There's 2 terms at the bottom. So it's negative 8 sin 2 theta plus 3 cos theta. Okay, so now the stand in the textbook. If the tangent is parallel to the y-axis, the denominator is equal to 0. Okay, so take the denominator and say negative 8 sin 2 theta plus 3 cos theta, and that's 0. Okay, now we just take to one side. So take rather the negative over. So say 3 cos theta equals 8 sin 2 theta. And now, I'm just trying to get everything and make it in terms of a tan. But, or let's see what happens here. Okay, so, oh, no. I have a 2 theta there. Oh, I will now see what I'm going to do there. So basically, that's the double angle. Do you see? So I can already write it in. But let's just we can first just divide by 8, and I divide by 8. Okay, so I have 3 over 8 cos theta equals sin 2 theta. But on page, you will find it on page 469 is that double angle. And what is, you can find it on this, because remember, I'm not differentiating, I'm simplifying. So that's why I work with trigonometry. So can I just show you the double angle trigonometry? Okay, I'm not busy with differentiation, just busy with trigonometry. So there's integration, I skipped it maybe. And where's the double? Let's just see that double. There. Do you see there? So it's 2 sin A cos A, but in this case, it's just going to be theta. So just go back. I could have first write it down. So it's actually, can I just go there? It's 3 over 8 cos theta equals, and now I'm going to say it's going to be 2 sin theta cos theta. Do you see that? Okay, now if I divide this side by cos theta, and I divide this side also by cos theta, whatever I do on one side, I do it on the other side. Then I have 3 over 8 is equal to 2 sin theta. Oh, now I still have a 2. So I divide 2 and I divide 2. So if you have 3 over 8, remember it's 2 over 1, and you multiply with a 2, then you get 3 over 16. I can swap the sides, and that's sin theta. Okay. And now I can go and I can say, and I think that is that. Okay, so let's just see. Sin theta, what was the question? Find the value of sin theta. They didn't want the theta, sin theta. I should have underlined it. Okay, so therefore, sin theta, and that's what they want. Don't go further, then it will penalize you. Okay, so let's go to that exam report and see what they say there. Okay, they say poorly answered. Very few candidates knew how to deal with the instruction that the tangent is parallel to the y-axis, and it stands very clearly in my textbook. They did not realize that any line parallel to the y does not have a x change. That means that the denominator of the derivative is equal to 0. Okay, and that's what we did there, and that's how we derived at the answer. Okay, and for now, it's my final video in paper 2, my final video of 2022 that I created in 2023. And I just want to say good luck with the exams. I always believe hard work pays off. Go through your basics. Go back to your textbook. Make sure you can do your basics. As soon as you can do your basics, you can start practicing exam type of examples. But good luck, and may God bless.